Okay, let's get into it. Today, we're doing a deep dive into some pretty serious infrastructure management.
We are. We've got the technical specs for the NTI E-1W environment monitoring system.
And our mission really is to look at this little box and figure out how it works as like a digital guardian for critical places that often don't have people around.
Exactly. At its heart, it's all about oversight. It's watching for the conditions that can cause catastrophic failures.
Things like temperature spikes, humidity, water on the floor.
Right. Water, power outages, someone breaking in, smoke. And it manages all that info securely over a standard network.
And I think the key takeaway here for you listening isn't just what it monitors, but how. It all comes down to this specialized one-wire sensor interface they chose.
Yeah, and one wire is so critical here. It's a really smart engineering solution. It lets both the data and the power for the sensor travel over, a simple pair of wires.
Which means you can have much longer cable runs, right? It simplifies the whole deployment.
It really does. It's way cheaper and easier than running, say, Ethernet to every single sensor. Think about a huge server farm. This is essential.
And the capacity, even with that simplicity, is pretty impressive. It has two of those standard RJ11 phone-style ports.
And across those two ports, you can connect up to 24 single-reading one-wire sensors. So that's your temperature probes, thermocouples, digital inputs.
24 inputs. That gives you a lot of eyes on a space.
It does. But this is where you, as an engineer, have to start making choices about resource allocation.
You mean with the combination sensors?
Exactly. You can use a combo sensor that tracks temperature, humidity, and dew point all in one unit.
Okay, so let's pause on that. That combo unit, it counts as 3 of your single sensors, is that right?
That's it. So you're trading quantity for data richness. You could have 24 simple sensors, or you could have a maximum of 8 of those really complex combo units.
It's a trade-off.
It is. They also made the setup really easy. They mentioned the sensors are hot pluggable, and they're detected automatically. That's a huge win for any tech working in a live environment.
And we're talking about serious physical scale here. The maximum cable length is up to 600 feet on each of those ports.
Depending on the setup, yeah, 600 feet.
So with that kind of scale, what happens when things actually go wrong? When a threshold is breached?
Well, that's when it stops being a silent guardian and starts becoming a very loud alarm. It uses multiple layers for notifications all at once.
So it's firing off emails, updating its own web page.
And crucially, it talks to standard network management tools using SNMP. That's how it integrates into a bigger monitoring setup.
But the real intelligence seems to be in the alert logic. I saw it has 32 standard alerts plus just one smart alert. Why only one?
I think that's a design choice. It favors simplicity and really reliable high-level thinking. That one, Smart Alert, is for true conditional intelligence, meaning you can set a rule like, if the temperature goes up 5 degrees in 15 minutes and the AC power sensor reports an outage, then you trigger a massive severity 1 event. It's about connecting the dots.
I see. So it's moving from just detection to something more like predictive crisis management. That's powerful.
And it's not just watching the room, it's watching the network too. It pings up to 4 other IP devices to make sure they're online.
And can even pull a live view from 4 IP cameras. All encrypted, of course. HDTPS, AES 256-bit, the works.
Okay, so that brings up a question. If this system is monitoring assets worth millions, a cold storage facility or a bank's servers, how reliable is the monitor itself?
Redundancy, that's the key. The standard model has dual redundant DC power supplies.
So a single point of failure is taken out of the equation.
Exactly. If the main power source fails, the unit it flips over to the second one automatically. No interruption at all. That's non-negotiable for these kinds of jobs.
And there's an even tougher version, right? The E-1WP.
Yeah, that one gives you triple redundancy. It adds power over Ethernet on top of the 2 DC inputs.
Now, there's a really fascinating, subtle detail in the specs about how it manages that power when you have 2 DC sources plugged in.
Go on.
The unit is designed to specifically draw power from the source with the highest DC voltage.
Okay, so when you put this all together, what does it mean for you, the listener?
Well, the E-1W is a really robust, integrated system. It's ideal for IT infrastructure, cold storage, basically in any unmanned area where stability is everything.
Right. And it really leverages the range and simplicity of that one-wire tech, effectively.
So let's leave you with a final thought on that power detail.
Yeah. Consider this. The system is specifically designed to seek out and draw power from the highest voltage source available to it. So what are the implications of that subtle technical choice? This constant internal search for the strongest power signal. What does that mean for how engineers have to design their own complex, redundant power systems in these ultra-high reliability environments? Something to think about.